Hello everyone, in this video let us solve this question. So we have 27 raised to power x plus x is equal to 0, and here we want to solve for the value of x. Okay, so in this video we're going to use two methods to solve this given problem. So method 1. Okay, method 1, the question which is 27 raised to power x plus x is equal to 0. First, move plus x over to this side. All we have is 27 raised to power x is equal to minus x. Then we're going to raise this equation to the power of 1 over x like this. So in brackets, 27 raised to power x, then all raised to power 1 over x is equal to, in bracket, minus x raised to power 1 over x. From this, applying this rule of indices, that if you have a raised to power m or raised to power n, this equals a raised to power m times n. Applying this rule right to this, power x, we cancel this, so we have 27 raised to power 1, which is still 27, equals, in brackets, minus x all raised to power 1 over x. And from this, we're going to bring this to this side of the equation and move the 27 to the other side of the equation. So this becomes minus x all raised to power 1 over x is equal to 27. At this junction, we are going to suppose let 1 over x equals minus y. So with this, if we simply cross multiply, okay, we have minus xy is equal to 1. Then divide both side by y, divide by y, we have that from here minus x is equal to 1 over y. So with this, to then solve for the value of x, the value of x is then equal to minus 1 over y by multiplying both sides of the equation by minus 1 by minus 1. Okay, so we get the value of x to equal minus 1 over y. So then we're going to input this value of x as minus 1 over y into this, and also the value of minus x as 1 over y into this also. So we have, for the value of minus x, we have 1 over y. So write down in brackets 1 over y, then all raised to power, we have 1 over x. And from here, 1 over x, right, x is minus 1 over y. So 1 over, we have minus 1 over y. And this is equal to 27. So this is equal to 27. So with this, we have in brackets 1 over y. Now, this 1 over in brackets minus 1 over y is simply minus y, and this equals 27. So what you are going to do is to apply this rule of indices. That if you have 1 over a, this equals a raised to power minus 1. So applying this rule right here, this becomes in brackets y raised to power minus 1 or raised to power minus y. This equals 27. So also applying this rule of indices, that if you have a raised to power b or raised to power c, this equals a raised to power b times c. Applying this rule right here, so power minus 1 multiply power minus y, we have y raised to power y, and this equals 27 can be written as 3 raised to power 3. So by comparing this, y equals to 3, y equals to 3, we have y equals 3, and with this, we have gotten the value of y, but the goal is to get the value of x. So from here, right here, recall that x is equal to minus 1 over y. So putting this down, that we have the value of x to equal minus 1 over y. With this, input the value of y into this equation. We have that for x is equal to minus 1, y is now 3 over 3. With this, we have the final answer to the value of x. So this is the final answer, okay, for the value of x. So this is for the first method. Now for the second method, right here, for the second method, we have method 2. So the equation, which is 27 raised to power x plus x is equal to 0. So what we are going to do is to divide this equation by 27 raised to power x, 27 raised to power x, 27 raised to power x. Once we do this, divide this, we have 1 plus x over 27 raised to power x is equal to 0 over this is 0. And with this, from here, move 1 over to the right hand side. This becomes x over 27 raised to power x is equal to minus 1. And we are going to apply this rule of indices that if you have 1 over a raised to power n, this equals a raised to power minus n. So applying this rule right here, this becomes x times 27 raised to power minus x and equals minus 1. At this junction, we are going to make use of the Lambert W function. So we call it the Lambert W function. So this function works when you have an expression like a times e raised to power a. Once you apply the Lambert W function to this, the value is equal to a. But then to apply this Lambert W function, we have to manipulate this to resemble this expression. So how do we go about it? First, look at the power right here. X right here is not the same thing as the power minus x right here. So we have to make the power equal to each other. And to do so, simply multiply this both sides of the equation by minus 1 by minus 1. And if we do this, minus 1 times x minus x, then times 27 raised to power minus x, this equals minus 1 times minus 1 is plus 1. Also, looking at the Lambert W function, we have e in the expression, but in this equation, there is no e in the expression. So we need to introduce a into this equation. And to do this, we're going to make use of this function that if you have e raised to power ln a, this equals to a. So also, this means that if you have e raised to power ln 27, this will equal 27. So in place of 27 right here, we'll bring in e raised to power ln 27, and this equation then becomes minus x multiplied by e raised to power ln 27 all raised to power minus x, and this equals to 1. From this, we're going to apply this rule of indices that if you have a raised to power b all raised to power c, this equals a raised to power b times c. So applying this rule right here, we have minus x times e raised to power. So minus x, we multiply the power, we have minus x times ln 27, and this equal 1. And also, if you look at this again, you will notice that this right here, minus x, is not equal to the power. And for us to make use of the Lambert W function, a right here must equal to the power a right here. So to do this, we are also going to multiply this equation by ln 27. So ln 27, then multiply this by minus x times e raised to power minus x times ln 27, okay, is equal to 1 times ln 27. And if we do this, we have ln 27 times minus x is minus x ln 27, then times e raised to power minus x ln 27. This equals 1 times ln 27 is equal to ln 27. So at this junction, we have minus x times ln 27, then times e raised to power minus x ln 27 is equal to ln 27 can be written as 3 raised to power 3. So from here, we have this minus x times ln 27 times e raised to power minus x ln 27 is equal to, so applying this rule of natural logarithm, that if you have ln a raised to power b, this equals b times ln a. So applying this rule right here, power 3 will come to this side, we have 3 times ln 3. Okay, so with this, we have minus x, then times ln 27 times e raised to power minus x ln 27 is equal to 3 ln 3. Also, we are going to apply the Lambert W function to the right hand side. Don't forget that the expression is like this: w into bracket a times e raised to power a this equals to a. So we're going to make this to resemble this expression. So how do we go about it? First, we're going to introduce e to this expression, and to do so, if you have e raised to power ln a, this equals to a. So if you have e raised to power ln 3, this equals 3. So in the place of 3 right here, we'll bring in e raised to power ln 3. So this expression becomes minus x times ln 27 times e raised to power minus x ln 27 is equal to e raised to power ln 3 times ln 3. And looking at the Lambert W function, e is in the second place. So move this e to stay in the second place. So this then becomes minus x times ln 27 times e raised to power minus x ln 27, and this equals ln 3 times e raised to power ln 3. Okay, so with this, we can then apply the Lambert W function to the equation. So we have w into bracket minus x times ln 27 times e raised to power minus x ln 27, and this equals w times ln 3 times e raised to power ln 3. Once we apply the Lambert W function to this expression right here, what we are going to have is this. We are going to have minus x times ln 27. And also, if we apply the Lambert W function to this right here, we're going to have ln 3. So writing down ln 3, this is equal to ln 3. At this junction, we are going to express 27 as 3 raised to power 3. We have minus x times ln 3 raised to power 3. This equals ln 3. And applying this rule of natural logarithm, that if you have ln a raised to power b, this equals b times ln a. So applying this right here, power 3 comes to this other side. We have minus 3x times ln 3. This equals ln 3. So therefore, divide both sides by ln 3. Okay, ln 3. This cancels this. We have minus 3x is equal to ln 3 cancel ln 3. We have 1. So from here, we are then going to divide both sides by minus 3 by minus 3. This cancels this. The value of x is equal to minus 1 over 3. Okay, so we have gotten the final answer to the value of x. Same thing also that we got for the first method right here, that we got the value of x to equal minus 1 over 3. So with this, the next thing is to verify if the value of x is the correct solution for the given question. So right here, let us verify this. Verify, we got the value of x to equal minus 1 over 3. And the question, which is 27 raised to power x plus x is equal to 0. So in putting the value of x into this equation, we have 27 raised to power x is minus 1 over 3. Then plus x is minus 1 over 3. And this equals 0. So from this, 27 can be written as 3 raised to power 3 into bracket minus 1 over 3. Then plus times minus is minus, minus 1 over 3, and this equals 0. From here, power 3 will cancel this 3. We are left with 3 raised to power minus 1, then minus 1 over 3, which equals 0. Following this rule of indices, that if you have a raised to power minus 1, this equals 1 over a. Applying it right here, this then becomes, we have 1 over 3 minus 1 over 3, this equals 0. So subtracting these two fractions, we have 0, which equals 0. Now, since they are equal to each other, this means that the value of x that we got as minus 3 is the correct solution for the given question. So with this, I hope you all enjoyed the video. Do well to like this video, subscribe to this channel. Thanks for watching. God bless you.